Hey, okay, guys. This is electrolysis. This is the last topic in Unit 9. It's been quite, it is the first day of winter break, 2020, and I've been working all day. Go figure. And this is, I think, my last video of AP Chem. Wow. I have about 150 or 60 of them. Not counting the 40, mistakes, videos that I had to delete, start all over. It's been quite a year. Christmas is in 4 days. 3. We're not having Christmas this year because my mom has COVID. She's had COVID for 12 or 13 days now. She's not bad, but she's really not getting any better, and we're worried, but we're actually not having Christmas this year. We'll postpone it. But I'm going to miss making these videos for you guys. I kind of feel like I'm here with you sometimes, or you're here with me. So, I don't know. Anyway, let's look at this. Not going out with a bang, right? We're just going to look at some conversions. Nothing too difficult here. Just look at some unit conversions, all right? I'm going to go ahead and share my screen. We're going to talk about electrolysis. This would relate to those electrolytic cells that we have not discussed too much, those cells that are not spontaneous, and those cells wherein we can plate out a metal that is not in its desired form, try to turn that metal into a solid, or maybe even you're trying to get a dissolved anion such as chloride. Maybe you're trying to get it to form a chlorine gas. Right, that would be an example of this. Okay, so what we have here is it's really all about your units, and they're hard to remember, to be honest with you. But this one's always easy for me to remember. Faraday's constant, right? It's a coulomb per moles of electrons. We know that a volt is a joule per coulomb. I don't think we'll be utilizing that too much here. I'm going to change the color there because those are separate. This will be a new one, I believe. Current. You will be given a current, or you will be asked for time and need to incorporate a current, okay? So you need to see that a current is given to you in amps, and an amp is a coulomb per second. So sure what that says over there. What word is over there? I would delete it. I copied and pasted that, so I don't know where it came from. So let's look at this. Let's just look at how these units could work, guys. I could be given grams. I could change my grams to moles. I could change my moles to moles of electrons. Okay, so like Zn2 plus. Every 1 Zn would have 2 moles of electrons. Okay, from there, I could put my moles of electrons into coulombs, because 1 mole is 96485. I could then turn my coulombs into seconds, and this is my amps. And I can now tell you, if you look at my unit, how long in seconds it took for you to plate out a certain amount of metal in grams, okay? Or it could be the other way around. You could be given a time, and you will then be given your amps, right? That's your amps. You could then turn your coulombs to moles of electrons using Faraday's constant. You could then turn your moles of electrons into moles of the metal. You could then turn moles of the metal into grams of the metal. So in that situation, you are given the time, maybe hours, you may have to convert your time, and you are asked for how many grams. Or you could stop anywhere in between there. They may have you stop here, right? Or here. You just need to look at your units. So what you see here is copper metal with its molar mass is purified, right? That's kind of what I was talking about. How many grams of copper can we get from copper 2 oxide? That means it is the Cu2 plus the 2 electrons yields the Cu, right? And we're going to do this for 12 hours, 10 amps. So let's see, we've got 12 hours. I don't want to do all those big lines. It gets on my nerves. I know that every 1 hour, 60 minutes. Every 1 minute is 60 seconds. If I look at my amps, every 1 second is 10 coulombs. There's 96485 coulombs in 1 mole of electrons. There's 2 moles of electrons for every 1 mole of copper that's formed. Every 1 mole of copper has a mass of 63.546 grams. Dang, that was easy. All right, so 12 times 60 times 60 times 10 times 63.546 equals, divided by parentheses 96485 times 2 close parentheses equals 1.42 seconds. Oh, grams, there. And we see that that's an option, 142 grams. Okay, notice letter A, that was if you forgot the 2. So they were prepared for you. How long would it take to electroplate a flute? So this time, think that you have a solution here, guys. And in this solution, you have silver. And you put that flute into the solution, all right? And you run a current through it. And it causes the silver to be reduced into silver solid. And it'll go all over that flute. So your flute is plated in silver. It has a silver coating. You could put a spoon in there. You could put a penny in there. Okay, so that's what that electroplating means. You bring it out as a solid and you give it something to adhere to. Okay, kind of cool, right? It'd be really fun to do. I've actually never done it. I've only talked about it. Okay, 28.3 grams of silver. There's 107.87 grams per mole. Every 1 mole of silver loses 1 electron. There's 1 mole of electrons, carries 96485 coulombs. Every 2 amps is 2 coulombs per second. So 2.0 coulombs for every 1 second. Our answers are in minutes. There are 60 seconds in every 1 minute. 28.3 times 96485 equals, divided by parentheses 107.87 times 2 times 60 equals, close parentheses. I've got 211 minutes, which is in fact answer A over there. I'm just going to say bye. I've got a lot of gifted Kim videos to make, so I guess I don't need to be too depressed today. I actually do have 1 more to make. I skipped 9.6. I don't really know what they want me to do, so maybe I'll be back. If not, it has been quite a semester. Good job.